Hello, this is Kim Nelson. In this tutorial, I'm going to go through, it's basically a refresher of taking a lot of the things we've been discussing lately in videos about how to make maquettes and how to turn that into refined surfacing and how to make a finished model from that. I want to go ahead and kind of summarize all of that in a single simple exercise, and that is to create a simple marquee ring, marquee dome ring. So this is the template file that you should have access to. If not, it's easy enough to make. It's a 17 millimeter ring bore and a 9 by 4.5 millimeter marquee. Okay, first thing I want to do is set up to do the drawing for this. I'm going to draw the front and the top views for this. To make the front view, I'm going to want to bring the stone up into position using Shift key. I'm going to want to offset this the standard, which would be, here we go, 2 millimeters. I'm going to move it up 0.3. I'll make it 0.4. It's a fairly delicate ring. So it's 1.6 at the bottom here. Okay. So now that I have that, I want to take a look and see how that very basic form is feeding into what I would like to do with this. I would like it to be a little bit taller up here on top. So I'm going to split out this profile curve, split it top and bottom, and then I will do a non-uniform scale. Pull it off the tabs, it's easier to follow. I can do non-uniform, or I can do scale 1D. Either one will work. You always start your scale from the place that you don't want to move, which in this case is at this lower quadrant. Holding Shift key, first point and second point. Something like that. Going to join these together. This is a little pinched feeling through the sides to me, so I'm going to go ahead and scale it again just a little bit. And this is just by eye, the whole thing. Actually, I don't want it to go up more, so I'll just do a non-uniform scale. I'll do non-uniform this time instead of this scale 1D. Just a little more width between the fingers there. And nothing changes and nothing changes. So there we go. These will be my two curves for the front view. I want them to have the seam at the bottom. So Rhino always likes to drop those on the side. So when you're doing a ring, they're either at the bottom or the top, and that depends on where you're doing most of your surfacing at. So there we have that. I want to make sure they have the same math. And for circles, I like to rebuild them to 36.4. Because I will be using flow kits. I want to start with the outside curve here. Start my top view. Measure the length. 67.089. Repeat that with the circle diameter, top C-plane. And we want to make sure that that is diameter. And then I can draw a curve from quadrant to quadrant. and check the lengths again. 67089, 67089. I'm going to rebuild this to the same math, 36.4, and that's done. Okay, so that will form the base for my top view. I'm going to draw a flattened top view. Like all the stones I use in my library, I have a girdle line as part of the stone. It's grouped in. I'm going to ungroup it and project it to the top C-plane. I actually, I'll go back and tell you what I actually did there so you can see it. I am ungrouping first so I can grab the curve. Then I'm going to copy it out to my clipboard. Then I'm going to undo the ungroup so that my original group is still here intact, and paste back in just the girdle line and project that to C-plane. The reason I do that is I don't want to lose the girdle line up here. I'm going to want that when I build a setting later. Speaking of building a setting, I'm going to do a bezel for this. I'm going to try an 8/10. 0.8. That's a little heavy. 0.7. Okay. For this type of ring, I'd like to go even thinner. 0.65. That's as thin as a casting is going to reliably work with. So now that I've got that, actually, I'm going to go 0.6. There. When you offset a marquee, it always does it with a large arc and 2 end pieces, or at least it typically does. So when I explode this, I expect to see 6 curves, which I don't want. Deselect those 2 little end pieces, join this back together, right, control click to remove that from selection, delete both of those, and then I'm going to rebuild this curve into a single curve. Actually, 9 isn't a bad number of points. That's fine. I like the odd number because it leaves a control point in the center for symmetry. Mirror. Join. So the rest of this is just drawing the top view. A little concerned as to why that's floating out there in space by itself. Perhaps because it's not on the same colored layer. That's right. So, draw a center line. Going to offset this through point both sides. Catch the end. Going to offset this curve to create kind of a soft frame around the stone, something like that. Once again, this is going to be that strange 6 segments, which I never have any use for. I'll remove these 2, join, control click to remove that from selection, throw that away, and rebuild this. And once again, the 9 works pretty well. I don't want a hard point. And I would like to mirror this with history. So I'm going to put a circle at each end. I'm going to use that to trim off the original curve which will update on the history. And then blend curve. And that's actually pretty nice. Holding the shift key down, I'll soften it a little bit. Mirror that. Join these together. Which broke history. The reason I put history on is in case I wanted to edit this curve. But they look nice, so. Decide what kind of taper I want on the shank here. I know that under the finger, I'm going to want to have about 3 millimeters at minimum. So that's already pretty good. I'm going to mirror this with history. And just play with his endpoint to create kind of the taper that I think I want. That's good. You know, yours can vary. This is just eyeballing. Can I actually explode this out now? Offset a curve, bring this back a little ways to give myself some breathing room between the shank and the center element. And then blend curve. Mirror that over. Delete that. Fine. And actually, before I mirror this over, there's one more thing I need to do. At the bottom here, this is where, as you'll recall, this will be underneath the finger. I need this to actually come off of a straight line so that it's smooth underneath. To get that, I'm going to actually run a blend curve. Between here and here. I'm going to back this quite a ways down. And bring that in. So that I have this transition that comes into the bottom here. I don't really like the way that looks. I could probably get by with 7 points. So I'm going to smooth it out a little bit. And mainly what will help is just to lift these up a little bit. And maybe drop this in a touch. I do not want to move anything up here because this is where my smoothness is coming in off of the center. And I want the relationship here to stay straight across. Using the point on point, then shuffle maneuver. I'm not sure this has remained smooth. I'm going to verify that it is by doing a curve. Edit tools match. It may have moved when I changed when I rebuilt. So I do not want to average curves. I want it to maintain curvature is fine, but tangency is also good. Yeah, it's fine. That curve is done. Joining it all together. And going to fillet the curve. And that's my top view. Complete. Now, it's important to remember that this is actually part of the flow kit. So I'm going to put it on the same layer as the front curves. And then I'm going to do a maquette. Join these together, and I'm going to extrude straight down. Deeper than I need. Cap, yes. Solid, yes, I should say. And I just want plenty of material so that it's thicker than the ring. And then I'm going to do, to maquette this, going to do a flow along curve. Here to here. Oops. Got to select what I want to flow first. There we go. And that's done. And I can use the inside curve to Boolean it out to the proper tapering thickness. Solid equals yes. Solid difference. Delete input equals yes, and click. And the Boolean difference failed. Extrude. Solid yes. This is what we had done before. So now I'm going to try that Boolean again. And it failed. Oh, hang on. I think I know what the problem is. See how these two end caps meet? Down here, that's going to create, I'll just hide that. Down here, that's going to create coincidental surfaces, two of them in the same place. And for a Rhino, that's very confusing math. So there goes one. And see, there's another one still in there. See if there's a naked edge left behind. There is. Okay. But that's just because there were surfaces there. I'll just close those up with the edge tool. The spacing will be negligible. There we go. Now the Boolean will work fine. Should. Yep. Put that in storage. And we have our maquette. There's our stone. Going to move that up a little bit. Something like that. Okay, so there's the maquette. I like how I've adjusted the stone. Now I need to flow that back down flat again. Okay, to do that I need to create an inner flow kit. So this is the outer flow kit. I need to create an inner flow kit. I'll put that on 3D3. Okay, so that's my curve. And the same process as before. Analyze length. 53,407. Starting at 0, 53.407 diameter. Drawing a straight line from quad to quad. Verifying the length. 53,407, 53,407. Rebuild this curve to match. Remember that was 36.4. I'll put it on the same layer. And so that now becomes my inside flow kit versus the outside flow kit. Okay. Going to now flow that maquette back down using the inside flow kit. Pick this inside curve in the flat front and this curve here. And that now is the surface I will be able to use to continue working with this. There are some strange things that are happening over on this end of the curve. I am not sure why that's happening, but I'm assuming it has to do with the seam on the bottom. I'm going to go ahead and put this in storage, the maquette. To verify whether or not that's a serious problem for me or not, I want to look at the top view and see if everything else looks symmetrical. It does. I'm fine. So I'm just going to cut off the crazy side, because this is just another maquette. This is just a flattened maquette. So, easy as that. All right, so there we go. So this curvature really no longer matters. The reason we flowed down is because it preserves your drawing. If you flow down from the outside, it preserves your drawing. Then when we flow back up from the inside, we will get the same result. So these curves are no longer really helpful to me. I'm going to reconstitute this. First thing I'm going to do to reconstitute it is I'm going to extract the back of it. Copy equals no. Like so. Join while they're still selected, because it's a poly surface for sure. And duplicate border. Going to extract the top two surfaces. Join them together. And I'm going to get a cross section from those using grid snap. I no longer need that. I no longer need that. Actually, back up. Rather than use the back of this, I prefer to use the top. It has actually less distortion. So, rather than these curves, I'm going to duplicate edges on top. I could have used the same curves on the bottom, but this will give me a more predictable result. Join, project to C-plane, and now I can either delete that or store it. Okay, want to rebuild these? I think that 35 or 45 should work. I can see that 35 is pretty good. I'll stick with that. I want them to be exactly the same, so I'm going to mirror this over. Delete one and mirror the other. Okay, and then I want to rebuild this into a single curve also. And this could be probably 25 points. Might even be okay with 15. Yeah, 15 is okay. So these are my new curves. Okay, I'm going to draw some straight lines at the bottom here to connect these. Turn off grid snap. Join this together. And now I'm going to reconstitute that maquette, but this will be actual surfaces that I use for my refined surfacing. Extrude straight up. Anything that's too long is fine. Extrude from the front. Fine. Trim this off. Fine. Trim that off. Fine. And if I join that all together and cap it, I will have recreated this same collection of pieces in here, but I will have done it with much more elegant surfacing, which is important because now we're going to use it to make our detailed surfacing, our refined surfacing. Put that away. All I need from this is a center line, which I already have, and I want to have a bumper for polishing. That bumper is usually good about 1 millimeter up. Do a cutting plane, throw that on the top C-plane, move it up in the front viewport 1 millimeter. So that would be a 1 millimeter bumper. I'm looking at what this does here. It doesn't give me much room for a cross section. And I would like a more elegant cross section there. So 1 millimeter is probably too much. I don't want to go below 0.7. So I'm going to take 0.2, move it down. That's 0.8 altogether. I like that. That's going to work. However, I don't want it to be a straight line for this ring. I would like it to follow along what this top is doing. So extract this, make a copy, yes. Untrim all. Hang on a minute, I asked to make a copy. It did, okay, good. Just wanted to make sure. I want to offset this surface, and I want to offset it until I get down to even with this roughly. Try 9/10. That's 9/10. That's not bad. I'll try 0.85. And it's got to be a negative direction because the arrows are pointing upward. So I want to go back. I want it to offset down. That is very close to what I want. Fine. I'll take it. And I would want to use this surface rather than a flat one. However, I don't want it to be consistent all the way across. I want a little more cross section up in front. So I'm going to rebuild this. Right now it's 25.2. I'll make it 15.2. 3.1 is fine. 4.1. Just a little more relaxed. I'm going to want to make it a little wider so that it's long enough to cut. So transform scale, either non-uniform or scale 1D, either one will work. Starting at 0, and just make it long enough. Turn on control points. I want to take these 3 points in the middle, 3 rows, and I want to drop them. And I'll grab this next set of rows, and I'll drop them slightly as well. Drop these 3 rows a little further still, and that's it. I'm going to use this to trim off the top. Before I do that, I will put these in storage so I have them. Copy, paste, group, storage. Trim off the top. So now I want to establish where I need cross sections. I'm going to need them at the 2 ends. I'm going to need one down the middle. I'm also going to want cross sections right here before it starts to curve up. So cutting plane there for sure. And I want to include this top curve in that group that I'm going to, in that selection that I'm going to cutting plane, because I want the cutting plane to reach across that top wire as well, for sure. That's probably enough. So I'm going to select these items again, this tray and the top wire. And I'm going to do section using grid snap. And this should look pretty familiar to those of you who've watched me do cross sections before. I just hid that cutting plane for a second. Start with point snap, pull straight back, blend curve, and there we go. Something like that. Mirror it over. Join. And now I'll unhide that and get an intersection between these elements. I can set a C-plane to this if I want, but it's actually parallel to the right C-plane, so it's not necessary. Although it is kind of comforting. It's nice to actually have the C-plane right where you're working, but it doesn't matter in this case. Right C-plane would have been fine. Straight curve back. Adjustable blend curve starting from this and going to here. I don't want that strange buckling going on, so that's fine. Mirror, join. Back to top C-plane, mirror, and there we go. Last C-plane is down here at the end. I can do what I did before, and that is just do a, no, I'm going to want a cutting plane, because there's nothing to snap to here. So and snap. And actually, no, I don't even need anything. I can use that, but I don't need to. I have everything I need already. Just do a line straight back from the end here. And I'm going to blend between here and the surface edge. Remember, a surface edge is the same thing as a curve in Rhino's mind. So soften that out a little, mirror it over, join, mirror from side to side. Done. So there are our cross sections. Now I'm going to sweep the surface. I have a single edge along both sides and then a curve. So I'm using surface and curve network, edge rail, curve rail, edge rail, cross section, cross section, cross section, cross section, cross section. Just like that. Join this together. We don't need these end caps. They'll actually only get in the way as we try and sweep, as we discovered the last time. They actually end up creating interior surfaces that are kind of a headache. We're going to take this curve network and I'm going to group it and put it in storage, curve storage. Bring this back, my flat flow kit, my inside flow kit. Transform, flow along curve, pick the flat inside, the front inside, and there we go. That's good. I'll go ahead and put this in storage. I'm going to move it back first so I don't have half a dozen things on top of each other on the storage layer. Bring up the stone. I'm going to ungroup the stone now. Actually, I don't need to do that. If I have my original top view, I can extrude I'll just copy it up. It's going to be easier. No grid snap. I'm going to want this to sit just below the table. Extrude straight down, top C-plane. Solid option, yes. I don't want it to go all the way through, so stop somewhere shy of that. And now I will take that girdle line. And I will extrude it straight up. Solid, yes. Like so. I want to make a cutter to open this up. So to create that cutter, I'm going to do an extrude to point and just grab the end of the pavilion, cule it. So I'm going to put these on a different layer. So it'll be easier to follow along what I'm doing. Since I extruded this solid, there are caps on each end. If I explode it, you can see them. I'm going to remove that one. So now I can create a closed shape with no interior surface, like so. I want to cut this off, so I'm going to, I can use isocurves or I can use cutting plane. I'm going to use cutting plane. Right, C-plane, anywhere at all, I don't care. because I'm just going to move this up by eye. I want to leave enough here that it creates a nice seat for the stone to sit on, and at the same time opens it up enough that light gets into the setting. That should work. Trim off the bottom. Duplicate edge or border. Extrude straight down. And join this together. That's the cutter for the setting. Cat planar holes, so it's a geometric solid. And that's it. Okay, so the ring is now complete, other than being hollowed out. Hollowing this ring, I'm trying to decide if I want to cover that in this tutorial. I really don't. So for this tutorial, I will stop after just combining these and opening up the setting. The problem is that gives you the wrong idea. It makes you believe that you could hollow the setting out. Right now, you wouldn't cut the setting until you hollowed the ring, just because it'll save you work. So I'll go ahead and hollow this. It's not hard to do. And I haven't, in this series, done any hollowing yet, so it'll be good to see. Extract surface. Copy equals yes. Going to grab the top and sides, all of them. Turn off the original. Surface. Offset surface. I'm going to make an even 1 millimeter. So the arrows are pointing in, so 1. And done. Delete the original. Going to offset this surface. That is the direction I want. Done. Offset and done. So here are my surfaces, and you can tell they're terrible surfaces. They're not surfaces that you would want to work with. And that's okay, because we're not going to work with them. We're going to use them as a guide. So I'm going to make a copy of this, and I'm going to put it on an unused layer. Turn off the original. I want to lock this layer. I do not want to select those accidentally. I'm going to use a cage editing box. So cage edit, bounding box, world, coordinates, and I like even odd numbers so they have center lines. X from right to left, 5 is fine. Y is also fine, 5. Z up and down here, I'm going to want more. Z, I'm going to go with 7. And there we go. Going to start by grabbing all of the control points. And I'll do a 1D scale. And what I'm trying to do is watch and see when these offset surfaces break through, because they're the indicator that are telling me when I've got a millimeter. That's pretty good. Okay. Now I'm going to scale them non-uniform, or 1D, whichever you prefer. I'll use non-uniform. Starting at 0, pull them in a little bit, nothing, and nothing. And you can see that is a little too narrow. So I think I'm actually pretty good there. So do it again, non-uniform. This time I want no change that way, so 1. And I do want to change it this direction. Now, if you've noticed, you could do this with the whole object and not the cage. You're correct, you could. But you're going to need the cage here in just a minute. So it was just as well to start working with it. I've almost broken through the front and back. That's a little too much. That's pretty good. Okay, so now I have it pretty much the way I want it. But in some of the tapers, it's really not pinching enough. So I'm going to grab this row. And this row, because I want to keep it symmetrical, and do a non-uniform scale. And actually, I'm going to grab the outer rows as well. Everything but the inside center row. Squeeze it a little more. And a little bit more. And I can see that that is just about to break through. A little bit more. There, I'm through. Doing this, of course, has left the center now too sparse, so give some meat back there. That looks pretty good. I'm a little bit low on top. grab. Just careful, make sure you only get the points you want. And go into a vertical C-plane so I can move them up. It's a little bit too far. You know, and these are very subtle distances, so if you're a little off, don't be too concerned. Okay, that's enough, because what I'm going to do now is I'm going to tuck up the bottom part of the ring. Well, actually I should taper that a little better. So either non-uniform or scale 1D. I keep alternating between them. Shift key if you're using scale 1D. And repeat it until you get and I don't need to break through down here. I want to come closer than I was. But that should be close enough. And one scale of this center section. Now, anywhere I see the brown is going to mean that I have hollowed less than 1 millimeter. Anywhere it's purple's surpassing it is where I'm hollowing it, you know, leaving more than 1 millimeter. That's pretty good. Pretty good. Okay. So now I'm going to take this strange object, grab the whole bottom half, and I'm going to scale it upward using, once again, either non-uniform or scale 1D. I'll use scale 1D. Going to come to 0, shift key down, and pull up. Now I'm just going to move it instead of scaling it. And what I'm looking for is for this to pull away at about halfway. That's good. Throw that box away. These guides can go into storage. I'll group them first. That's my cutter. Copy, paste, group, storage. Solid difference. That was interesting. It's doing it in reverse, so you can try and strategize and find out why Rhino doesn't like it. Why Rhino dislikes this, it's very hard to tell. These are both solids. Oh, that isn't a solid. That's the problem. These are both open. Okay. I assume they were closed. They're not. That's the problem. And this one isn't closed because that one wasn't closed. Easy to fix. Show edges. Yep, it's down here at the bottom again. When it wraps around, that's always the problem area right there. Analyze edge tools, join two naked edges. And that's going to be the same location where this one's having problems. So, same sequence. And Boolean difference. When you do this, it means Rhino doesn't like having those joined together. That's fine. So we're going to ignore the fact that it hates it. There's the difference right there. It's done. Extract surface. And you can see it's a very strange surface with all kinds of problems. And that's all right. We're going to delete the surface. That inside curve is right here. Extrude it. Try and trim it with the surface. I expect we may have to pull curves. But it's worth a try. Yeah, no. Duplicate border. Delete those curves. Duplicate border. And join. And there we go. That's been hollowed. It didn't give me a comforting little flash saying all was well. Yeah, we're going to need to join this in. That's it. Closed surface. Done. Now, we have our setting. Right here. Now, so that this doesn't drop down in, I either would have Booleaned it in first before I hollowed, or after the fact, it's easy to do as well. Make a copy of this surface, and you extrude it. Offset it just a little, 0.2 of a millimeter is fine. Minus 0.2 in this case, because you don't want it to intersect with this. You want it to be inside. Analyze direction. It's pointing the right way. Solid difference. Solid union. Now, before I do that, I might want to take a look and see if I think that's too tall, too high. If I move that, I want to move the cutter as well. Maybe a little bit. Solid union. Solid difference. Here's the cutter, by the way. If I take that away, you can see that this will now cut the seat. If I want to fill at the edge of this for a little more finished look, I can. It won't matter because this will all be pushed over in the setting anyway. And a hard edge is actually friendlier to the stone setter, but still. If you'd like a little softer effect, there you go. And that's it. Finished dome ring for a marquee stone. So it's a good way to put the tools we've just learned through their paces. I'm sorry the hollowing didn't go as smoothly as I'd hoped, but that happens. Booleans and you know, the fancier, the more intricate your surfacing becomes, the more flexible you have to be about how you may solve problems. But there you go. It's finished. Thanks for watching.